Hello everybody. My name is Willie Sylvain,
My name is Ryan Lawrence.
and this is our project, the PyBot. Sorry, you can't see the picture. Our project was to create an object-avoiding robot using Raspberry Pi. The program will be written in Python. If you could see the picture, it would show the components that we used. And we did a little trick by, instead of using a battery, we used a wireless rechargeable one for a cell phone. It wasn't that heavy and it worked perfectly fine. So it powered up the drivers, the motors, and the Raspberry Pi.
What is that second sentence of on this line? What is that?
The program should be written in Python.
That's not what it says there.
Typo.
No?
When we change themes, it probably caused a typo.
The scope and limitations. The sonar sensor is only capable of detecting objects within its 35-degree radius. Anything out of its scope, it doesn't detect it and it just keeps going until it hits it. Another limitation is the Wi-Fi adapter produces high latencies. So no matter what command we would put in, sometimes it doesn't get read by the adapter and the robot will just keep going as well until it hits the wall. The Raspberry Pi cannot produce the 4 PWM signals required to operate the motor driver. We used
a PWM driver to compensate for that. So our PWM driver is actually connected to the Raspberry Pi via the I2C interface, and you control the driver via the Raspberry Pi through some simple programming. Here we have a simple circuit diagram that we use. So right here, we have the Raspberry Pi connected to the PWM driver, and so we have the SCLA and the SDL ports connected to the driver, which are the I2C pins needed to register on the Pi. We also have the sonar sensor connected to GPIO 23 and 24. But because the GPIO returns a 5-volt high signal, we had to use a voltage divider here that connects to pin 24, because the Pi cannot read 5 volts. If you try to set 5 volts to a GPIO pin, you would actually burn out your Pi. And from the PWM driver, it's connected to our motor driver. Now the reason we needed PWM signals is that the speed of the motors is controlled via the input signals, and the input signals have to be PWM for that to be for the speed to be controlled. Next, we have like a separate power supply which is needed to control to generate enough current to power 2 motors.
Why do you need 4? You only have 2 motors.
For what?
4 PWMs.
Okay, the reason we needed 4 PWMs is because each output for the for one motor, it has 2 outputs and 2 inputs, so it reads just like an H-bridge for direction control. So one input has to be high, one input has to be low in order for you to run the motor in a certain direction. If you want to run it in the reverse direction, you would reverse the inputs as well. So that's why we needed 4 inputs, because each motor requires 2 inputs each. Any more questions? Okay, next slide. All right, so the way we programmed this Pi is that we broke up all the code into 2 scripts, because it would have been extremely long. So right now we have the drive code. This is just a basic script containing the functions needed to set the PWM signals for the PWM driver so that it can drive the motor driver. So in the first line, you see we imported a library from adafruit.com that was provided with the PWM driver. Next, we set PWM equals PWM OX40 debug true. Now this line specifically tests to see which version of the Raspberry Pi you have and sets the I2C address. Version 1, I believe it's located on port 0, and version 2 of the Raspberry Pi, I believe, is located on port 1. So you don't have to remember that because of this line of code here. Next, we set the PWM frequency to 1000 like a default. So we define 3 functions in this specific script. We define a function to stop, a function to move forward, and a function to turn. Now, in the turn function, we use the stop function here specifically because you don't ever want to suddenly switch directions of your motor. This can cause like a back current that could damage the components, specifically your motor driver. Any questions? All right, next slide. Now this is the main code that's executed in order to run the robot. So first things first, we have to be able to measure the distances. So we define a simple measuring function, and then we define another function to take the average because the way the sonar sensor is designed, if it detects an object at an angle, it would cause false reading because the ping signal would bounce off that angle, go to some other location, and then come back, and that would provide false readings. So we just took an average as a sort of countermeasure to that, but again, it's not 100% accurate still. So after we set up our average function, we get to the main part of the script where we define what pins are our trigger, what pins are our echo, and then we use a while loop, a continuous, like try loop actually, my bad. We use a continuous try loop. So the reason we use try is that we want to be able to read like keyboard interrupts. In order to stop this program, you would have to press Control-C. So while true, we would drive, measure distance, and if the distance is less than 30, we would invoke the turn function. And then whenever we press Control-C, we would stop and then clean up the GPIO assignments.
I'm guessing it's 30 inches?
Pardon me?
30 inches?
30 centimeters.
Centimeters?
Yes. Next slide. And that's it, time to present.
Go back. Demonstration.
Can you go back to the whole graph where you have the block diagrams?
Sure.
Can you go over this again?
Okay, so now this is just like a basic circuit diagram we use to design a robot. Now, the main part, the Raspberry Pi here. Now, you have to be careful when connecting inputs to the GPIO pins because you always want to test to make sure that you're supplying 3.3 volts. So that just to make sure everything you connect to the Raspberry Pi, if it's an input, has to be 3.3 volts. So we connected the Raspberry Pi to the PWM driver via the I2C interface. Next, we connected the sonar sensor to the GPIO pins 23 and 24. Pin 23 is the trigger which supplies a 5 volts to the sonar sensor, but the echo pin here is connected to a voltage divider because the echo pin returns 5 volts as well. So we cannot use the 5 volts, so we use a simple voltage divider, 2 resistors in series, take the output from the middle, and connect that back to GPIO 24, which is our echo pin. So once we are able to set the PWM signals using a program, it generates this chip here, the PWM driver, generates the PWM signals we need that become the input for our motor driver. And our motor driver then, based on whatever inputs we have, if we have a PWM signal in input A and a 0 signal in input B, depending on how we coding it, it would drive motor 1 clockwise. If we reverse the inputs, like 0 on input A and a PWM signal on input B, it would reverse the direction of the motor.
So how many inputs do you need for the PWM driver?
Inputs for the PWM driver, you need about roughly 4. 1 for power, 1 for ground, and 2 for the I2C interface.
That was my question. For the controller itself, it's only 2,
Yeah.
right? High and low.
For how to control the driver itself,
Yeah.
I'm not
I mean, what kind of signals do you need to go into the PWM?
those are just, I believe it's serial. It's a serial connection to the I2C interface.
Mhm.
It does. You don't send like standard high and low signals to the driver. It doesn't read high and low signals.
So it has to be I2C?
I2C, yeah. Because it's not connected to the GPIO 23. It's connected to special pins on the Raspberry Pi.
Mhm. Where are the sensors on that graph?
The sensor
The
is
ultrasound sensors.
right here. The HCSR04.
Those are the 2 sensors?
It's just one sensor.
No, I mean, one to send and one to receive.
Yeah. The sensor sends out a ping signal.
Mhm.
The ping bounces off an object, and then the echo, it waits for an echo. Once it receives that echo, it sends a high signal.
So on that graph, who is receiving the information from the sensors?
The Raspberry Pi is receiving the information.
Well, no, what kind of data is that?
It receives digital. It receives high and low. It either receives a high signal from the echo or a low signal from the echo.
Okay. So you actually have the sensors. I mean, the sensor has not shown on that graph. The sensors themselves, you don't show the sensors there. You're showing the module that receive. Well, there you go. How long was that?
12 minutes.
30 minutes.
Right? Okay.
Now you can see the circuit.
You get my point?
Or you want to see an actual picture of the sensor?
No. I mean, you have 2 sensors, right? One that sends and one that receives.
Yeah, but it's all on one module.
Uh-huh. Okay. I see.
It's not 2 separate modules. It's all just one module.
Uh-huh. So you say they receives zeros and what do they send out?
What?
What do they send
What
out?
does the
What kind
sensor
of-
send
Yeah.
out? It sends out a ping signal, which is a sound wave.
Sine waves. Okay. And who's sending that signal out? Yeah.
The sensor itself, the sensor has 2 components on it. It has,
Uh-huh.
for lack of a better term, a speaker that
Right.
sends out the
Mhm.
ping, and it has a
Microphone,
microphone
right.
that listens for that echo.
Mhm. And you say that the Pi is processing that information?
No, the module actually processes that information and returns high or low on the echo pin.
Oh, so the Pi is just receiving a 0 or a 1?
Yeah, and
So
then
it
you
will not go-
use like simple math to
Uh-huh.
you start the timer for when you send the ping out, and then you wait for whenever the Pi receives the echo, and then you stop the timer, and then you use that information to do some calculations on the Pi to determine the distance.
Mhm. I mean, I might get back to you with more questions, when I read the paper.
Okay, go back and show the pictures.
Yeah? Mhm.
So yeah, see, it's a single module with a speaker and a microphone. This is our PWM driver. Our motor driver is nested here. And this is just a simple cobbler that connects the GPIO pins to the breadboard for easier access. And this is just a battery pack.
And the PWM has enough power to drive the motors?
It doesn't drive the motor driver. The motor driver is connected to the battery pack, has its own battery pack connection.
Uh-huh.
The PWM driver just provides the inputs, that's it.
Uh-huh.
It runs off the 5 volts. It runs off 5 volts that's provided from the pipe. PWM logic, PWM driver.
So you're using external batteries for the motors?
Yes. You have to use external batteries because the pipe cannot supply enough current needed for the motors. And everything was written in Python.
Okay.
Any questions?
Questions? Comments? Suggestions?